Hi, Nikki. Let's look at part A of that problem that you gave me, and we'll start working out that one, and then we'll go from there. If you want more videos, let me know. Just let me know how this video works for you. So we're going to focus on part A, which was before 1918, in a random sample of 9 wolves spotted in the region, what's the probability that 6 or more of them were male? So let's just write down some of the facts that we know. So if we were to randomly select just one wolf, there is a 55% chance that that wolf would be male, which means there's a 45% chance that wolf would be female. So those are the probabilities that we're going to use for our binomial distribution problem. Now, we want to know the probability that 6 or more were male if we choose 9 of them. So what we want here is a probability that 6 or more are male. Now, another way to write that is the probability that x is greater than or equal to 6. So in this case, we would let x be the number of male wolves that we find when we choose a group of 9. So if we choose 9 wolves, x represents the number of male wolves in that group of 9. Now, greater than or equal to 6 means when you have a group of 9 wolves, exactly 6 of them could be male, or 7 could be male, or 8, or all 9 of them could be male. So this problem involves a lot of stuff here because you have to find the probability that you get exactly 6 males, or the probability that you get exactly 7 males, or the probability that you get exactly 8 males, or the probability that you get exactly 9 males, which means when you choose a group of 9 wolves, they're all male. So we have to find 4 separate probabilities and then add them all together. And that'll be the probability that in a random sample of 9 wolves, that 6 or more of them are male. Let's just focus on one of them for now. Okay, let's just start with finding the probability that we'll get exactly 6 wolves. So I'll go through and explain how to do that one for you, and then the rest of them will be the same process. We'll just have to change the numbers for 7, 8, or 9 wolves. Okay, so let's kind of just draw a little diagram here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's say these are 9 spots for the 9 wolves that I'm going to choose. So I'm focusing right now on finding the probability that exactly 6 of those wolves are male. So if 6 of them are male, I would have 6 males and 3 females. Now, keep in mind, that's just one way to get 6 males. I don't have to get all 6 males first and then 3 females at the end. But first, let's just figure out the probability of that, and then we'll see how we just repeat that iteration over and over again as many times as it's possible to get 6 wolves. So right here, if I have 6 male wolves, that means I have a 55% chance, or 0.55 to the 6th power, because it's 0.55 times 0.55 times 0.55, and so on. And that means the other 3 wolves would be females, so it would be 0.45 to the 3rd power. So if I multiply the 0.55 to the 6th power times 0.45 to the 3rd power, let's see what I get. So let me do it real quick. So 0.55 to the 3rd power times, 0.55 to the 6th power times 0.45 to the 3rd power. Okay, it says round answers to 3 decimal places. So this is 0.00. I'm going to go a little bit farther because this is not my final answer. So we'll say 0.00252. So that's 5 decimal places, but that's okay. All right, now, so what that is, this number right here, this isn't my final answer by any means, but this number tells me what would be the probability of when I choose 9 wolves, The first 6 that I count are male, and then the last 3 are female. But keep in mind what I said. That's not the only way to get 6 males. 1, 2, 3, 4, 5, 6, 7, 8, 9. I could get a male first, and then a female. And then male, 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 and then 2 more females at the end. But now I still have 1, 2, 3, 4, 5, 6. I'm still going to have 0.55 to the 6th power, and 1, 2, 3 females, 0.45 to the 3rd power. They're just in a different order. But when you multiply, you can group the numbers however you want. So even though they're not right next to each other, this would still be 0.55 to the 6th power times 0.45 to the 3rd power. So it would be this same answer. So no matter how many ways I can get 6 males and 3 females, each one of those ways would have this probability of 0.00252. So what we have to figure out is how many ways can I get 6 males? When I choose a group of 9, how many different ways or how many different arrangements can I get my 6 M's and my 3 F's? Okay, so let's do that on the next slide. So let's now talk about the combination. Okay, so if you're allowed to use your NCR button, what we want to figure out is if we have 9 wolves, how many ways are there to choose 6 of them that are male? Okay, so if you do 9 choose 6 on your calculator, you get 84. So what that means is 3, 4, 5, 6, 7, 8, 9. I'm going to draw another one of these diagrams out. Let's get 6 males in here and 3 females. Okay, so what that 84 means is that there's 84 ways to do this, meaning there's 84 ways to put 6 M's and 3 F's in those 9 blank spaces. So there is 84 ways to do it times the probability of each individual one, which was the 0.00252. Okay, so let's see what we get for that. So we're going to get 0.2188, so we'll say 0.212. Now, that's just the probability of getting 6 males. Remember, we wanted at least 6 males, so we still have to figure out 7, 8, and 9 males. But let's kind of write a formula here so we can get it a little bit more organized and then set it up to find 7 males, 8 males, and 9 males. So what I just did, I just found the probability of getting exactly 6 males. So what that is I did my 9 choose 6, and then I multiplied that by the probability of a success. So in this case, we're calling choosing a male wolf a success because that's what we're looking for, to the 6th power, and then multiplying that by 0.45 to the 3rd power, because if I had 6 males, I have 3 females. So notice this exponent and this exponent should always add up to that total number of wolves right there. So if I have 6 male wolves, the leftover should be 3 female wolves. So those exponents should always add up to each other. But now remember, we still have to do this for 7 wolves, 8 wolves, and 9 wolves. Okay, so let's go on to the next slide, and let's just reiterate what we said at the beginning. So the probability of at least 6 wolves means I have to find the probability of exactly 6, and then add that to the probability of getting exactly 7, and then add that to the probability of getting exactly 8, and then add that to the probability, add that to the probability of getting exactly 9 wolves. So I'm going to do these all in one line, and then we'll add them all together. I'm going to do them all in separate lines, and then we'll add them all together. So we already found the probability of getting exactly 6 wolves. It was 9 choose 6 times 0.55 to the 6th power times 0.45 to the third power. Then I'm going to find the probability getting exactly 7 wolves. So now it's going to be 9 choose 7. So now I'm saying, okay, if I have 9 slots, how many different ways can 7 of those slots be males and 2 of them be females? So the probability of a success here is still 0.55, but now I want that to happen to the power of 7 because it's 7 of them in a row. So what do you think the exponent should be for females? It should add up to 9, so 2, 7 males and 2 females. Now we have to find the probability of exactly 8 male wolves. So that would be 9 choose 8. So the probability of a success is 0.55 now to the 8th power. So that means if we had 8 males, we'd only have 1 female. So the exponents are 8 and 1. And then we need the probability of all 9 of them being male wolves. So that's 9 choose 9. Now 9C9 is only going to be 1 because if you have 9 spots, there's only one way to fill them all with males. So it's going to be 0.55 to the 9th power. Now we still fill in the 0.45, but it's going to be to the 0 power because 9 plus 0 means there's 0 females. And 0.45 to the 0 power is just 1, so it's not going to change the answer, but it's just nice to see that the exponents should add up to the whole. Okay, so let's go ahead and start finding the individual probabilities. So this one was 0.212. Okay, I'm going to work the other ones out on my calculator, and you can do it right along with me if you want. I probably should have figured these out before I started recording, but that's okay. So this 9 choose 7, there's 36 ways to do that. So 36, and then I'm going to multiply that by 0.55 to the 7th power and 0.45 to the 2nd power. And I get 0.11098, so we'll say 111. All right, let's do the probability of getting exactly 8 wolves. So 9 choose 8, there's only 9 ways to do that. So this 9C8 right here, there's 9 ways to do that. And then I'm going to multiply that by 0.55 to the 8th power, and then times 0.45 to the 1st power. So this is, this is 0.0339. We'll keep the 9 there because it's 1 after the 9. All right, and then the last one, 9C9, there's only one way to do that, and 0.45 to the 0 power is 1. So really all we need to do here is 0.55 to the 9th power, which is 0.00, we'll say 46, it's 4605, so we'll say 461. So now, to get my final answer, I need to add all of those together. So 0.212 plus 0.111 plus 0.339 plus 0.00461, and dun dun dun, drum roll, the probability of getting at least 6 male wolves is 0.667. So I hope that helped. If you need me to clarify anything, just go ahead and send me a message. And if this helped, I can, make more for you. I just wanted to see if this helps you before I make any more. So just let me know. And like I said, I hope this helped, and I'll talk to you later. Bye.